All right, last part here. We've got solve each equation for all theta in radians. And we can do this in degrees as well, but and actually I think we will do it in degrees just to illustrate it to you. Now remember cosine and sine, they're talking about the angle made on the circle here. Let me go ahead and draw the unit circle. Uh, and let's put in a triangle. So here's our angle theta, and I'll do it here in green, theta. Okay, and that can be anywhere on the circle, but it's going to be a periodic function because the circle just continues going around. If you got to 360 degrees and then just kept on going, that'd be fine. You would just keep on going around the circle until you used up all your degrees, and then wherever you're at, you would solve for theta. And so here we go. Remember, let's write that up. Sine and cosine are periodic functions. And so it says for all theta in radians, and we'll add in degrees as well, in degrees. And since we're going to solve for all theta, we need to include, like once we get our answer, we're going to add 2 pi, there's radians, to the answer because that's another circle around. And so for all of them, we need to multiply that then by n, where n is going to be some positive or some integer, because it doesn't need to be positive, where you could, however many times around the circle you went, you really were getting right back to the same value. So we're going to add either 2 pi n or 360 degrees times n. So we can include all answers for theta. All right, so let's go through this. Cosine of theta equals 1. And so where would cosine equal 1? And so we've got cosine of theta, that's equal to adjacent over hypotenuse. And so where would the adjacent over hypotenuse give us 1? And that's going to be only here at, let's go with pink, only at 0 degrees, because the adjacent side is your x value. So you can think of that also as x over the hypotenuse or over the radius. That might be a better way to think of it on this one, is x divided by the radius. And there we go. So we've got an x value of 1. That radius is 1 as well. And so we get the value of theta when the cosine of 1 when our theta is 0. So theta equals 0 plus 360 degrees n. Remember, we're adding that in because you could go around the circle 1 time, 2 times, 3 times. So maybe it's 360, 720, so on and so forth. But all those theta give you a cosine of 1. If it was in radians, it'd be 0 plus 2 pi, or that's the full circle in radians, times n. Oops, it's a ugly n. Times n. There we go. There's our answers for where does cosine of theta equal 1. All right. Now sine of theta equal -1. So when does sine of theta equal -1? Remember, sine is opposite over hypotenuse. And so we're looking for where on our unit circle do we get a value of -1. And so as we go around, remember that's the y value is our opposite. So this is the y value divided by the radius of 1. And so up here we get +1. That's not what we're looking for. All back to 0, and then the y value divided by the radius. So the y is -1 and the radius is 1. So here we are. It's when we're at either theta equals 270 degrees plus 360 degrees n. And so that could either be multiple times around positively, or you could have a negative n. And the n value does need to be, should have included that earlier, but n, make a little asterisk here, n is an integer, because we're talking about full times around the circle. How many times around the circle did you go? That's what we're adding and subtracting out of here. In radians, well, that's going to be, remember, pi is 180 and 90 degrees. That right angle, that's pi divided by 2. And so pi divided by 2 multiplied by 3. That's where we get down here. And so that's 3 pi over 2. And then plus 2 pi times n. There's all our values that give us a sine value of -1. And lastly, cosine of theta equals, and I want you to pause the video and really think about, how would I get -3 here? How would I get -3? So I hope you have paused and considered that. So cosine being adjacent over hypotenuse, which for us is going to be our x value divided by the radius. And the only way to get -3 is if our x value is 3 times larger than our radius. But that doesn't make a lot of sense. We were saying that the adjacent side would have to be 3 times bigger than the hypotenuse, but the hypotenuse is the biggest piece, so that isn't possible. So there actually is no solution. No solution for theta, giving us a cosine of -3. All right, hope that helped.